Hello, good morning, students. From the last video, I discussed integration by parts technique. So I'm going to do more examples. So we will do definite and then some boomerang questions. So I will tell you what is the boomerang question. So let's do the first example. So we need to integrate from 0 to 1. The function is x squared e to the power negative x dx. So you can see that there's a product x squared then e to the power negative x. So then we need to use integration by parts and figure out u and dv. So choose. So in this case, I will go with u equals x squared and dv as the rest, which is e to the power negative x dx. Now we need to compute du and v. So since u equals x squared, I can take the derivative, then du over dx, we get the derivative of x squared, which is 2x. So from this we get du equals 2x dx. So that is our du. And then next we can compute v. So since dv equals e to the power negative x dx, so I'm going to integrate both sides with respect to, so left hand side with respect to v and right hand side e to the power negative x dx. So if you integrate 1 with respect to v, you get v. And now we need to compute the integral of e to the power negative x. So if you cannot do this directly, so I will show you how to do directly. If not, you can use the substitution u equals negative x and then compute the derivative, the integral. So we know that antiderivative of e to the power something, that we will get the same thing. So in this case, we have e to the power negative x. And then we will take the derivative of negative x, which is -1. So we divide by -1. Divide by -1. Then we get v equals negative e to the power negative x. So that's how we will apply this directly. So if you are not still familiar with this, you can do your substitution and get your answer. Now we have all required details to apply the formula. So next, apply the formula. So we can write integral u dv, that is uv, minus integral v du. So remember, in this case, this is a definite integral. So we have boundary from 0 to 1. So we have to substitute 0, 1. And also evaluate this from 0 to 1. And we have 0, 1. Now we can substitute u, v, du, and dv. So then we get the integral. So this is from 0 to 1. So we have u, which is x squared, times dv, which is e to the power negative x dx. So we have u, which is x squared, times v, that is negative e to the power negative x. We evaluate from 0 to 1, minus integral from 0 to 1. So we have negative e to the power negative x, and du we get 2x dx, 2x dx. Now we can simplify this before we evaluate. So we have negative x squared e to the power negative x, evaluate from 0 to 1. So minus minus we get plus, integral, and we can bring this 2 outside. So we have x e to the power negative x dx, and left hand side we have 0 to 1 x squared e to the power negative x dx. Now we can evaluate the first term of the right hand side. So substitute x equals 1. So I'm going to use different color to show this. So if we substitute x equals 1, we get negative 1 squared e to the power negative 1 minus, now we are going to substitute 0. So we get negative 0 squared e to the power 0. Now we have plus 2 times, so integral from 0 to 1, 0 to 1, x e to the power negative x dx. So we can ignore this term because it is 0. So we get, so this would be negative, this is 1, negative e to the power negative 1 plus 2 times integral from 0 to 1 x e to the power negative x dx, and this would be integral from 0 to 1 x squared e to the power negative x dx. So now again we have to apply the integration by parts for this term. Apply integration by parts again. Now we have to choose u and dv differently. Then we have to choose again. So I'm going to use green color to do this. Now in this problem, I will take u as x and then dv as e to the power negative x dx. Now we have u and dv, so we know what we need to do next. Compute du, which is du over dx. We get the derivative of x, which is 1. From this we get du would be dx. And then next we need to compute v. So we integrate both sides. So we have integral negative x dx. So integral of v, integral of 1 with respect to v, get v. And so again we are going to use, if you cannot do this, you can use u substitution again. So we know that antiderivative of e to the power something, that would be e to the power that, which is negative x here. Then we take the derivative of this exponent with respect to x, so that would be negative 1. So we divide by negative 1. So v would be negative e to the power negative x. And again we can apply integration by parts. So integral, so this would be from 0 to 1 u dv, that is uv from 0 to 1 minus integral v du from 0 to 1. So I can substitute u and dv and v du, everything. So in this case u is x and dv is e to the power negative x dx, and u is x, v is negative e to the power negative x, evaluate from 0 to 1 minus integral from 0 to 1 v, which is negative e to the power negative x, times du, that is dx. Now we can simplify. So we have negative x e to the power negative x from 0 to 1. So this would be 0 to 1 x e to the power negative x dx. Now we have minus minus, we get plus integral from 0 to 1 e to the power negative x dx. Now substitute x equals 1 and x equals 0. So if we substitute x equals 1, we get negative 1 times e to the power negative 1 minus, if we substitute 0, that would be e to the power 0, and then we need to compute the antiderivative of e to the power negative x. So as we did earlier, so this becomes antiderivative of e to the power negative x divided by the derivative of negative x, which is negative 1. So we need to evaluate from 0 to 1. So that is integral from 0 to 1 x e to the power negative x dx. So we can ignore this term because it is 0. So we get negative e to the power negative 1, and we have plus, this becomes negative e to the power negative x from 0 to 1. So that is the integral of x e to the power negative x dx. Now I substitute x equals 1 and 0. So we get negative e to the power negative 1 plus, so if we substitute 1, so we get negative e to the power negative 1 minus, if we substitute 0, that becomes negative e to the power 0. So we have negative e to the power negative 1 plus times minus, we get minus e to the power negative 1. So this becomes plus. So remember e to the power 0, which is 1. So we can substitute it next step. So we have x e to the power negative x dx. Now we can simplify. So we get negative 2 e to the power negative 1 plus, so this is 1. So that is the integral from 0 to 1 x e to the power negative x dx. Now I'm going to substitute this value to this integral. So I will take this as equation 1. Now substitute into 1. So we have equation 1, which is integral of x squared, integral from 0 to 1 x squared e to the power negative x dx, x squared. So we have negative e to the power negative 1 plus 2 times this integral, which is same as this. So we can substitute that value. So negative 2 e to the power negative 1 plus 1. Now we can simplify. So multiply by 2. So negative e to the power negative 1 minus, so this becomes 4 e to the power negative 1 plus 2. So you can add these two, negative 1 e to the power negative 1 minus 4 times e to the power negative 1, that becomes negative 5 e to the power negative 1 plus 2. So that is the answer, x dx. So that's how we will use the integration by parts to compute the value of definite integrals. So now I'm going to talk about the boomerang problem. Boomerang means if you throw a boomerang, that will come back to you. So in this problem, we start with one integral, and after some steps, then we get back to the same integral. So that's why we say boomerang. So let's do this. We need to integrate integral e to the power x. sine x dx. Now this is called a boomerang problem. Called a boomerang problem. So in this case, you can choose either e to the power x or sine x as u. So if you use u as e to the power x, then next time if you use another integration by parts, so go with e to the power x as u, don't mix with. So that's what you need to do for this problem. You can choose either one as u. So you can choose u equal e to the power x, or you can choose u equal sine x. It doesn't matter in this case which one you use, you will get back the answer, same answer. So I'm going to use u equals e to the power x and dv as sine x dx. So next step we need to compute du and v. So I will take the derivative of u with respect to x, so which is derivative of e to the power x. So remember, derivative of e to the power x is the same, e to the power x. So from this we get du, which is e to the power x dx. Now we need to compute v. So we have to integrate both sides, dv, so integral of sine x dx. So integral of 1 with respect to v, we get v. Now we need to compute the antiderivative of sine x. So remember, which is negative cosine x. So that would be the v. So if you want to check, take the derivative of this negative cosine x, then you should get sine x. That's how you can see if you got the right antiderivative or not. So in this case, if I take the derivative of cosine, that would be negative sine. So minus negative sign, that becomes plus sign. So that means we have correct v. Now apply the integration by parts. So we have integral u dv equals uv minus integral v du. So in this problem, u is e to the power x, so I can substitute that, and dv is sine x dx, sine x dx equals, so u, which is e to the power x, times v, which is negative cosine x, negative cosine x, minus integral v, which is negative cosine x, times du, which is e to the power x dx. Now we can simplify. So we have integral e to the power x sine x dx. So we have negative e to the power x cosine x. So minus minus we get plus integral e to the power x cosine x dx. Now again we have to apply integration by parts to this integral. For this, apply integration by parts. So as I said earlier, we choose u as e to the power x. So in this problem also we have to go with the same, otherwise you will go back to the same integral without doing anything. So in this case, let u equals e to the power x, and then we have to go with dv, which is cosine x dx. So now we can apply, we need to compute du. So du over dx, that is the derivative of e to the power x, which is same. So from this we get du, that is e to the power x dx. And then we will integrate the dv expression to compute v. So this would be dv integral cosine x dx. Now we can integrate 1 with respect to v, which is v. An antiderivative of cosine is sine x. Sine x. Again, you can check whether you have the right v. So take the derivative. So derivative of sine is cosine. So we had the same thing. That means we have the correct one. Now you can apply the formula. So integral u dv equals uv minus integral v du. Now I'm going to substitute this. So integral, in this case, u is e to the power x, and dv, which is cosine x dx, equals u times v. So u is e to the power x times v, which is sine x, minus integral v. So we have sine x times du, which is e to the power x dx. Now we can rearrange. So we have integral e to the power x cosine x dx is e to the power x sine x minus integral. So I will write down ex first and then sine x dx. So we have this integral. Now we can substitute this integral to this equation. So this is our equation 1. Now we are going to substitute this to equation 1. Substitute into 1. So we can write down equation 1, which is integral ex sine x dx. Integral ex sine x dx equals to, right hand side we have negative e to the power x cosine x, e to the power x cosine x, plus, then we have this integral. So we found it, this whole thing. So we have e to the power x sine x minus integral e to the power x sine x dx. Now you can see that, so we have same integral left hand side and right hand side. So you can see we start with e to the power x sine x, and now we have some term along with the same integral. That's why we call it boomerang. So we came back to the same problem. So what I'm going to do, I will add this integral both sides, sine x dx. I'm going to add the same thing, ex sine x dx. Then I can cancel out these two. Now we get, so if we add these two, we get 2 times integral e to the power x e to the power x sine x dx equals to the right hand side, which is negative e to the power x cosine x plus e to the power x sine x. Now I can factor out e to the power x from these two. Then we get negative cosine x plus sine x. That would be 2 times integral e to the power x sine x dx. Now I'm going to divide both sides by 2. So divide by 2 and divide by 2. So we can cancel out 2 from left hand side. Then we get the answer for integral ex sine x as, that would be 1/2 times e to the power x. We have negative cosine x plus sine x. So that would be the answer. So you can, so that's how we will handle the boomerang problem. So if we choose u as one term, so you have to use the same thing when you apply the integration by parts again. Otherwise, you will not get this answer. So let's do another. So remember, we have to add a constant. So let's add a constant c, where c is a constant. So now we are going to do a definite integral. So we have to evaluate integral from 0 to pi over 2 e to the power x cosine x dx. So now this is a boomerang problem with the limit. So this is the definite integral. So we will do the same thing. So figure out u and dv. So in this case, you can choose u as either e to the power x or cosine x. Doesn't matter which one you use. So let solution. So let u equals e to the power x and dv, that would be cosine x dx. Now I'm going to compute du and v and then apply integration by parts. So du over dx, that is the derivative of e to the power x. So this would be the same, e to the power x. So we can write du as e to the power x dx. So next we are going to integrate dv expression to find v. So this is 1 dv integral cosine x dx. So if we integrate 1 with respect to v, so this becomes v, and antiderivative of cosine is sine. And again, you can check if you take the derivative. So derivative of v, we get dv, and derivative of sine would be cosine. So we get the same answer. Now apply integration by parts. So we have u dv, that would be uv minus integral v du. So remember, this is a definite integral. So we have these two boundaries from 0 to 90, 0 to pi over 2, and we have to evaluate this from 0 to pi over 2, and this is from 0 to pi over 2 as well. Now we can substitute our u dv and v du, those things. So we have integral from 0 to pi over 2. So we can substitute u, which is e to the power x, and dv is cosine x dx equals u, which is e to the power x, times v, that is sine x, from 0 to pi over 2, minus integral from 0 to pi over 2, v, which is sine x, times du, which is e to the power x dx. Now let's evaluate this integral. So we have 0 to pi over 2 e to the power x cosine x dx. So we can evaluate this term. So first substitute pi over 2. So we get e to the power pi over 2 times sine pi over 2 minus, now we are going to substitute 0, e to the power 0 times sine 0. So minus, now we have integral from 0 to pi over 2. So first I write e to the power x and then sine x dx. So we know that sine 90 is 1, sine 0 is 0. Then we can simplify this integral. So we have 0 to pi over 2 e to the power x cosine x dx is, so we get e to the power pi over 2 minus, so this term is 0, so we can ignore that term, minus integral from 0 to pi over 2, we have e to the power x sine x dx. Now again, remember this, we have to apply again integration by parts. Apply integration by parts. So we will pick u, which is same as the previous one. So u we pick as e to the power x. So we need to go with the same. So u would be e to the power x. And so dv in this case is sine x dx. Now let's compute du. So du over dx is the derivative of e to the power x, which is same. Then we get du is e to the power x dx. And then we can integrate dv to compute v, integral sine x dx. So integral of 1, we get v, and antiderivative of sine x is negative cosine x. If you want to check, take the derivative. So derivative of v is dv over dx, and derivative of cosine, you get negative sign, so that would be minus negative sine, so that become positive sine x. That's what you have here. Now we can apply the integration by parts formula. So u dv equals uv minus integral v du. So remember, this is a definite integral. So we have to substitute 0 to pi over 2 and evaluate this from 0 to pi over 2, and integral from 0 to pi over 2 v du. So let's substitute from 0 to pi over 2. So u is e to the power x times dv, which is sine x dx, equals, so we have u, which is e to the power x, times v, which is negative cosine x, So we have to evaluate from 0 to pi over 2 minus integral from 0 to pi over 2 v, which is negative cosine x, times du, which is e to the power x dx. Now let's simplify this. We have negative e to the power x cosine x, evaluate from 0 to pi over 2. So minus minus we get plus, integral from 0 to pi over 2. This is e to the power x cosine x dx. So this is integral from 0 to pi over 2 e to the power x sine x dx. Now let's substitute pi over 2 and then substitute 0. So if we substitute pi over 2, that becomes negative pi over 2 times cosine pi over 2 minus, then we substitute this, x equals 0. So we have negative e to the power 0 cosine 0. And then we have this integral, which is from 0 to pi over 2 e to the power x cosine x dx. And we have this integral from 0 to pi over 2 e to the power x sine x dx. Now I'm going to substitute this integral to equation 1. Before that, we can simplify. So cosine 90 is 0 and cosine 0 is 1. So then you get integral from 0 to pi over 2 e to the power x sine x dx is, so we have minus minus, we get plus 1, and then the other integral from 0 to 90 e to the power x cosine x dx. Now we are going to substitute this into equation 1, which is this. So substitute this into 1. So equation 1, we have integral from 0 to 90, integral from 0 to 90 e to the power x cosine x dx, 0 to 90 e to the power x cosine x dx, which is equals to e to the power pi over 2 minus this integral. So we compute it as 1 plus integral from 0 to pi over 2 e to the power x cosine x dx. Next I can multiply by negative, so then we can simplify this. So we have integral from 0 to pi over 2 e to the power x cosine x dx. So we have e to the power pi over 2 minus 1 minus this integral pi over 2 e to the power x cosine x dx. Now we have now we can bring this integral to the other side to simplify. So I'm going to add this integral to both sides, e to the power x cosine x dx, and then add integral from 0 to pi over 2 e to the power x cosine x dx. So we can cancel out these two integrals. Then we have, so if we add these two, we get 2 times integral from 0 to pi over 2 e to the power x cosine x dx equals to e to the power pi over 2 minus 1. Now we can divide both sides by 2, then we get the required answer. So divide by 2 and then whole thing divided by 2. So we get integral from 0 to pi over 2 e to the power x cosine x dx is 1/2 e to the power pi over 2 minus 1. So that is the answer. So that's how we will evaluate this. So so usually if we have e to the power something times cosine or e to the power something times sine, so that would be the boomerang question. So only combination of these two. Next I will do one example, then that would be the end of this video. I'm going to evaluate the following integral. So evaluate x to the power 10 times ln of x dx. So let's write down solution. So in this case, we will choose u as ln x because we don't know the antiderivative of ln x. That's why we will pick this as u. And dv is x to the power 10 dx. Now we can compute du over dx, which is derivative of ln x, that is 1 over x. From this we get du, that would be 1 over x times dx. Next we can compute v, so we have to integrate dv expression, so integral x to the power 10 dx. Now so integral of 1 we get v, and integral of x to the power 10, that is x to the power 10 plus 1, 11, divided by 11, so that is our v. Now we can apply integration by parts. So u dv, that would be uv minus integral v du. So in this case, u is ln of x times dv, which is x to the power 10 dx, equals u, which is ln of x, times v, that would be x to the power 11 over 11, minus integral then v, which is x to the power 11 over 11, times du, that would be 1 over x dx. So we get x to the power 11 over 11 times ln of x minus, so we can bring 1 over 11 to the front because it is a constant. So then we can cancel out 1x from the numerator and the denominator. So you get x to the power 10 dx, x to the power 10 ln of x dx. Now we have to compute the antiderivative of this. Remember, this is not a integration by parts, so because we don't have two terms here. So x to the power 11 over 11 times ln of x minus 1 over 11. So the antiderivative of x to the power 10 is x to the power 11 over 11 plus some constant. So that would be this integral. Now we can simplify. So integral x to the power 10 ln of x dx we can write as x to the power 11 ln of x over 11 minus, so if you multiply 11 times 11, so that would be 121 x to the power 11 plus this constant c. So that is the answer. So if we have some term which we don't know the integral, so we will choose that term as u and then proceed the integration by parts. So that's the end of today. So we will do chapter 7.2 in the next video. So redo this example and get the idea.